In this presentation, you will see that the TCP/IP consists of a variety of protocols, each of which has a specific role in transmitting and receiving data over a network. The OSI model is divided into 7 layers, 6 of which are consolidated into the TCP/IP model. The 4 layers of the TCP/IP model are application, transport, internet, and link. Software to interface with specific network topologies is not part of TCP/IP. Each of the upper 3 TCP/IP layers contains one or more protocols that perform different functions within TCP/IP. 6 of the most commonly used application layer protocols are HTTP, the Hypertext Transfer Protocol, which is used to access the World Wide Web, FTP, the File Transfer Protocol that can be used to copy files over the network, SMTP, the Simple Mail Transfer Protocol that makes it possible for you to send email over a network, DNS, the Domain Name System that is responsible for looking up a host's address so that you can connect to it, RIP, the Routing Information Protocol used by routers to exchange routing information with each other, and SNMP, the Simple Network Management Protocol that enables you to manage servers and other devices over a network. There are 2 protocols at the transport layer. TCP, the Transmission Control Protocol, is connection-oriented, which means that it negotiates and maintains a connection between 2 hosts. It uses the connection to ensure that a recipient is ready to receive a packet, to acknowledge to a sender that it has accepted a packet, and to retransmit packets that have not been acknowledged by the recipient. TCP is called a reliable protocol because it ensures that data is transmitted accurately. UDP, the User Datagram Protocol, is a connectionless protocol. When it sends a packet to a host, it does not check that the recipient is ready, and when it receives a packet, it does not acknowledge it. Because it does not send the large number of messages that TCP uses to ensure that packets are delivered, it requires much less bandwidth than TCP. UDP is used by application layer protocols, such as DNS, to transmit short messages such as name queries and responses. Like TCP, UDP rejects corrupted packets. Because UDP cannot guarantee packet delivery, it is often called an unreliable protocol. Streaming media often uses UDP because of its low overhead. Most media players buffer enough of the arriving data to be able to request a new copy of a bad packet from the sender and receive it before it is needed. The main protocol at the Internet layer is IP, the Internet Protocol, which manages the movement of packets between sending and receiving hosts. It is responsible for routing packets to their destination, dividing them into sizes that will fit through the routers along their route, and addressing packets. An IP address is a series of numbers that is assigned to the physical hardware address of a host. The Internet layer includes several other protocols. ARP, the Address Resolution Protocol, that looks up the physical address linked to an IP address. IGMP, the Internet Group Management Protocol, is used by routers to track group membership on a subnet. And ICMP, the Internet Control Message Protocol, that carries error messages and provides simple diagnostic capabilities. TCP/IP does not require a specific network topology. It uses functions at the link layer to create frames and send them over the network. The hardware interface is managed by the network operating system. Here is an example of the way the TCP/IP protocols work together to perform a simple operation. A coworker has emailed you a link to a document that is on a different host. When you click on the link, your application uses your DNS client software to request that the DNS server send the IP address of the destination host to you. The DNS client software uses UDP and IP to build a DNS name query message to request the IP address of the host you want to connect to. Link layer functions build an Ethernet frame and pass it to the network operating system to be sent to the DNS server. The DNS server sends back a DNS name query response message with the target host's IP address. It comes in through the link layer, goes through the IP layer where the addressing information is stripped off, goes back through UDP where the packet's integrity is checked, and then up to the DNS client software. The DNS client software passes the IP address of the target host onto the application. Your application instructs TCP to create a connection. After the TCP connection is established, the application requests the file from the target host. The target host uses TCP to segment the file you want into packets and send it to your client. Each packet comes in through the link layer, through IP, and passes up to TCP, which verifies the segment's integrity and holds it until all of the file segments have arrived. It also acknowledges receipt of the packet to the sender. This cycle repeats until the whole file has been reassembled. If a packet arrives that does not pass the integrity check, TCP discards it and does not send an acknowledgement to the sender. Because the last packet was not acknowledged within the allotted time, the sender retransmits it. When the last packet arrives, the file is reassembled and acknowledged to the sender. Then the client closes the TCP connection. The completed file is passed up to the application where you can access it.